So hello everyone, today we see some more examples of a calculation of oxidation number. Okay, let's see an example in NH3. So we have to find out the N. Next, N2H4 and 2O5 and 3H. So they calculate the oxidation number of nitrogen in these compounds. Okay, so nitrogen take X, 3 hydrogens. So hydrogen we know that 1, it's a neutral molecule, 0. So X equal minus 3. So oxidation number of nitrogen is minus 3. Here 2 nitrogen, 2X, 4 hydrogens, 4 into 1, overall 0. Minus 4, X equal minus 2 means nitrogen also shows minus 3, minus 2 also. Here 2 nitrogen, 2X plus 5 oxygens means generally oxygen having minus 2 number. Okay, 5 into minus 2, overall 0. Okay, 2X is 5. So it is a maximum oxidation number of nitrogen because nitrogen having valence electron 5 కాబట్టి దానికి plus 5 extra వచ్చే చాయిస్ లేదు. So N3H 3x plus 1, 3x equal minus 1, x equal minus 1 by 3 means here we have to remember the oxidation state of an element in the compounds may be positive, may be negative, or it may be in fractions also. Free element already we know that it's a 0 1 means based on the molecule compound it may exhibit positive, negative, or sometimes fraction oxidation state also. It is the best example for that. Okay, so next we see some more examples. That is NH4 NO3. It is a total different compound. So NH4 NO3. There is a one other different compound is there. That is Fe3O4. Here iron find out chali, here nitrogen find out chali. So actually what is the difference of this compound? And actually the name. So direct 2x తీసుకోకుండా దీన్ని split చేయాలి. But how to know it? We have to remember. So it is actually the combination of these two ions. ఈ nitrogen మనం separate గా calculate చేయాలి. So this is x plus 4 hydrogen 1 overall charge into the overall charge power 1 ఉంది. Okay, so x equal to 1 minus 4, x equal minus 3. So then separate calculate that x plus 3 into minus 2 overall charge. So this power minus is not on the oxygen, not on the nitrogen, this is on the total NO3. Here also this plus 1 is not on the nitrogen, not on the 4 hydrogen, it is overall charge is plus 1. Is x minus 6 equal minus 1 equal how much? So plus 5. So what are the oxidation numbers of nitrogen in that ammonium nitrate is? So minus 3 comma 5. Okay, next see Fe3O4. So Fe3O4 లో సో ఇక్కడ మనకి 3 చాయిసెస్ ఉన్నాయి దీన్ని క్యాలిక్యులేట్ చేయాలంటే నార్మల్గా మనం 3x ప్లస్ 4 ఇంటూ మైనస్ 2 ఓవరాల్ 0, 3x minus 8 equal 0, 8 x equal to 8 by 3. Okay, we can do like this but based on options from multiple choice maybe 8 by 3 ఉండకపోవచ్చు. There is also other possibilities. So what are other possibilities of this is actually it is taken into two parts, FeO plus Fe2O3. So then two parts laga consider chestam. So Fe3O4, so x oxygen minus 2, so x equal to 2. Here it is 2x minus 6 equals 0, 3 into minus 2. Okay, means the oxidation numbers are 2 comma 3. See some more examples. For example, it is also very important one. So bleaching powder. So bleaching powder. So we know the uses of bleaching powder. Okay. So it is to kill the germs. It is used in the water. Okay, it's called bleaching powder. What is the chlorine oxidation state? So now I'll calculate them. So calcium second group, so +2. O -2, it is 2x. Overall power 0. So that is 2x equals 0. So x equals 0. So the overall oxidation, nothing but oxidation number and 0. So actually here it is also given sometimes -1, +1. So మనం 0 కాబట్టి -1 +1 రాయట్లేదు ఇక్కడ. So actually it is, if you see its structure, it is like this. This is CaOCl2. So the chlorine which is connected to the electronegative element, it shows +1 number. So the chlorine which is connected to the electropositive element, it shows -1. So మనం 2 combined గా 2x తీసుకొని క్యాలిక్యులేట్ చేస్తాం కాబట్టి we got 0. But sometimes answer is also given -1 +1. So it is also correct. So next in sulfuric acid, so sulfur. Next we calculate other one, H2SO5. Here also sulfur. So calculate the oxidation number of sulfur in these two compounds. We know it's the name of this compound, sulfuric acid. So no need to write again. Sulfur +6 oxidation set, it's okay. But in H2SO5, so for example general calculate చేసామనుకో 2 + x oxygen -10, here H will get 8. But sulfur, as we see, in its valence electrons only 6. But you got 8, means it is not correct one. Okay, very wrong in calculation. It's exactly correct, but x got 8. The sulfur oxidation 8 is possible. It is not possible because it is having only 6 electrons. So it's the 6 electrons lose hote +6 avutadi. So kabatti it is not possible. So what the difference is, actually its name is Peroxy monosulfuric acid. Peroxy monosulfuric acid, it is also known as Carros acid. So sulfur find out cheyandi, 2 + x. So what is the specialty of this component? It is having one peroxy bond. One peroxy bond, and already we said that O single bond O is called peroxy bond. The oxidation number -1. So ఇక్కడ H2SO5 లో one peroxy bond ఉంటుంది. So one peroxy bond అంటే the two oxygen are having -2 plus 2 oxygen are having -1. Next remaining 3 oxygens normal, that is -2. X equal 6. Okay, so it is important to know how the peroxy bond is so present in it. So how it exists in the Carros acid and this is a H2SO5. So here, this is called peroxy bond. This is the peroxy bond on 2 oxygens ke -1. So remaining 3 oxygen normal oxygens kabatti -2 -2 -2. So 3 oxygens ki -2. So 2 oxygens ki peroxy bond unnayi kabatti we are taking that's a -1. So this is the structure of H2SO5. So in the model we have one more compound. So it also have one peroxy bond. Its name is peroxy disulfuric acid. It's also known as Marshall's acid. Marshall's acid. Sulfur. So 2 into 1. One peroxy bond means 2 oxygen having -1. So remaining 6 oxygen normally -2. One peroxy bond. So we have to remember. So what is this structure means? Here see how many peroxy bonds are present. So we can see there is a 2 peroxy bonds are present. Sorry, only one peroxy bond, 2 oxygens. So -1 -1. There is a 2 into -1. Remaining 1 2 3 4 5 6. Remaining 6 are having normal oxygens -2. Okay. So next we have one more example. Chromium peroxide. So find it for chromium. So ఇక్కడ మనకి we must know the chromium peroxide having 2 peroxy bonds. So 2 peroxy bonds ఉంటాయి దీంట్లో మనకి. How many it means chromium? So 1 double bond O. So here 1 peroxy bond between 2 oxygens. So ఇప్పటిదాకా మనం చూసిన examples లో only 1 peroxy bond ఉంది. But in this example there is 2 peroxy bond, just like butterfly structure అంటాం దీన్ని. Okay, 2 peroxy bonds are present. 2 peroxy bonds అంటే so this O -1, this O -1, this oxygen both, and then 4 oxygen are having -1. It is only the normal oxide, so that is only having -2 number, means plus 4 oxygens -1, just 1 oxygen -2. Means the chromium number is +6. Okay. So మరి ఏ కాంపౌండ్ లో పెరాక్సీ బాండ్ ఉంది, ఏ కాంపౌండ్ లో పెరాక్సీ బాండ్ లేదంటే సో జస్ట్ ఆన్ స్టడీస్ ఓన్లీ వీ విల్ గెట్. జస్ట్ మన కాంపౌండ్ చూడగా అన్నోన్ కాంపౌండ్ చూసి దానిలో పెరాక్సీ బాండ్ ఉందని ఇట్ ఈస్ నాట్ పాసిబుల్. ఇట్ ఇస్ నాట్ ఈజీ టు నో పెరాక్సీ బాండ్ ఈజ్ ప్రెసెంట్ ఇన్ ఈ కాంపౌండ్. సో మామూలుగా మనకి సో డిఫరెంట్ ఎగ్జాంపుల్స్ ఇస్తే వీ హ్యావ్ టు రిమెంబర్ ఇన్ విచ్ పెరాక్సీ బాండ్స్ ఆర్ ప్రెసెంట్. Take take C6H12O6. We know this. What is the name? So what is the name of this compound? It's a glucose or fructose. Glucose and fructose both are having same names. Glucose formula same, fructose formula is also same. Next we see. So it is a glucose or fructose. I will have to write this only. Next C12H22O11. So what is this? It is called sucrose. Sucrose, even we can say maltose. Maltose formula would same. Even we can say lactose. Lactose. So it is same formula. So calculate the carbon oxidation number here. 6x plus 12 into 1. 6 oxygens minus 2 equals 0. Overall charge 0. Take 12x plus 22 into 1 plus 11 into minus 2, overall charge 0. Means in glucose, fructose, sucrose, maltose, lactose, in all these compounds carbon is having 0 oxidation state. So it is forming different bonds, overall oxidation number becomes 0. So see next. So this is the carbon compound. So here also carbon oxidation number. So దీనికి కూడా మనం 2 parts చేస్తాం. So how it is splitted means CH3 plus CH4 minus 2 parts split చేయాలి. Otherwise we will get so combined also రావచ్చు, but actually this is the original form. It's 1. So 1 O minus 2 is minus 1. So x equals 0 means oxidation number is minus 2 comma 0. Overall just we will get 2x. So the 2x minus 4. So now we are combined state lo chesi chudam. Okay, combined the 2 carbons kada, 2x plus 4 hydrogen 4 into 1 is equal 0. 2x so plus 2 equal 0. So 2 carbons kada, 2x 4 hydrogens, 1 oxygen will get minus 2 0. 2x plus 2 equal 0, 2 is equal minus 2, so x equal to minus 1. Each carbon is having minus 1 oxidation number. So here also minus 2 comma 0. So oxidation state minus 1 becomes minus 2 comma 0. Okay. Now we see oxidation state of some ions. H4 plus. What is the name of this ion? Ammonium ion. So nitrogen final shell. Ammonium ion. 4 into 1. So what is the overall charge? Overall charge 1 plus 1. So next sulfate S44 minus 2. So sulfate and what is the sulfur? What is the overall charge? Minus 2. Next, what is an oxalate ion? C2O4 minus 2. Oxalate. Here 2 carbons. So 2 is overall charge. Means each carbon, X equal to each carbon is having plus 3 oxidation state. Okay, next one more. Already we done that dichromate ion. Okay, potassium dichromate. Already we done Cr2O7 minus 2 dichromate ion. Overall charge minus 2. Already we done in K2Cr2O7 potassium dichromate lo manam potassium తీసేస్తే we'll get Cr2O7 minus 2. It's the same. So this is very important and simple, easy topic. So it is useful in the total redox reaction chapter. Manaki based on oxidation state tone which are oxidation reactions, which are reduced reaction, మనం find out చేస్తాం. So other definitions now, the main useful is the oxidation number concept. Is helpful in the calculating oxidation number. Okay. So now we see one more compound, Na2S4O6. So what is the sulfur oxidation state? So 2 sodiums, no doubt 1. So 10 by 4, it is average 5 by 2. Sodium thiosulfate. Sodium thiosulfate. What's its number? So next already we done bleaching powder. So next so Ki3. What is the iodine oxidation number? So what potassium adige choice le, because potassium lo there is no change, it is fixed one. So potassium lo other than plus 1 there. So kabatti potassium 1 plus 3x overall 0. So 3x equal minus 1. So x equal minus 1 by 3. So next one more important one, H3PO5. So H3PO, what is the name of this compound is peroxy phosphoric acid. So peroxy, so it is also having one peroxy bond. So already I said that we have to remember these compounds. X 5 oxygen, 1 peroxy bond ఉంటుందంటే 2 oxygens minus 1, remaining 3 oxygens normal minus 2. So 3 plus X minus 2 minus 6. Here 3. Sorry. Okay. So 3 plus X. So it is the maximum oxidation number of phosphorus, as phosphorus has 5 valency electrons in it. So can you guess, can you write the structure of H3PO5? So try to write the structure of H3PO5 now. We know that so H3PO5, it is just like a H2SO5. H2SO, here H3PO5. Okay, H3 are there. H3 and already we have only 2 hydrogens. So 2 hydrogens, like H3PO5, 1, 2, 3, 4, 5 oxygens, 3 hydrogens. So here it is the peroxy bond. These 2 are having minus 1 numbers. So remaining 3 are having minus 2 numbers. Okay. So next. So take another example, potassium chlorate. What is the Cl oxidation number? 1 plus X. 5. Okay. So means Cl. So ఇక్కడ important one. Cl general గా మనకి 17th group element కాబట్టి it shows -1 oxidation is common oxidation number అది. Fluorine, chlorine, bromine, iodine లో. So they belong to 17th group and nothing but 7th atom. They have 7 valency electron in its outermost shell. So కాబట్టి by taking 1 electron they become stable. So కాబట్టి -1 common oxidation number. But based on the compound, so a compound formed this time low. So depending on other atoms, they may show some positive oxidation numbers also. So fluorine country there is no other choice -1, but chlorine shows +1, +3, +5, +7 oxidation state also. Very rare cases it also shows positive +1. Oh, that is have a hypochlorous acid. So hydrogen 1, oxygen -2, sorry. What means so chlorine shows +1 oxidation state also, +5 also. Next bleaching powder has 0. So next tomorrow we see some more different examples. Okay, you have to practice these questions. Okay, so tomorrow we see the different examples.